Hello friends, let us start with Unit 7, that is Introduction and Objective of Averaging. Average means, it's a commonly used in day-to-day conversation, this term. The first and foremost objective of statistical analysis is to get one single value that represents or describes the entire data. And such a single value is called average or a central value. Now, definition of average is, proper definition is, according to the different statistician, according to the CLAR, average is an attempt to find one single figure to describe whole of figures. According to A. Bowley, averages are statistical constants which enable us to comprehend in a single effort the significance of the whole. According to the Croxton and Cowden, an average is a single value within the range of the data that is used to represent all the values in the series. Since an average is somewhere within the range of the data, it is sometimes called a measure of central value. Properties of good average are, first property, it should be based on all observations. It means where all the data used give best results, whereas average which use less data are not representative of the whole group. Second, good average should not be unduly affected by extreme value. It means no term should affect the average too much. If one or two very small or very large items unduly affect the average, then the average cannot be really typical of the entire group. So thus, extreme terms may distort the average and reduce its usefulness. For example, to find the average of 6, 8, 10, we get mean as 8, but if another item having value 200 is taken, the average comes out to be 56. So hence, it can't be called a good average, as with only one new item, it has increased from 8 to 56. Next is, good average should be rigidly defined. There should be no confusion about the meaning or description of an average, and it must have a rigid or to the point definition. Next is, good average should be easy to calculate and simple to understand. Next is, good average should be capable of further algebraic treatment. It means it is used in many other techniques of statistical analysis. The measure of like the measure of dispersion, correlation, etc. Good average should be found by graphic methods also. It means we can draw the graph from the data sets also. Good average should not be affected by variation of sampling. It means it will be least affected by sampling fluctuations. If a few samples are taken from the same universe, the average should be such as the least variation in values derived in the individual samples. The results obtained will be considered to be the true representative of the universe in this case. Next is, it should not be affected by skewness. Skewness means asymmetrical distribution. We will not call an average good one if it is affected by skewness present in the distribution. It means it is affected by asymmetrical data set in the distribution. So we will not call as a good average. Good average should be absolute number. Good average should be possible to find central tendency for open and class interval. In many distribution, ends are open. So a good average is one which can be calculated even in open class intervals. Open class intervals means the first and the last figure is not given in the data set. Good average should be popular. It means which is known to common people will be more useful and a simple person will be able to understand it. Good average should have a clear and stable definition also. Next is objectives of average. First, to describe the central tendency of the data. Means statistical average provide a measure of central tendency of the data. They help in summarizing the data set by providing a single value that represents the entire set. The most commonly used measure of central tendency are the mean, median and mode. Next is to provide a representative value. Statistical average provide a representative value that can be used to make comparison between different data sets. They help in understanding the pattern of the data and make it easier to interpret the overall trend. Next is to facilitate analysis and interpretation of the data. Statistical average facilitates the analysis and interpretation of the data. By simplifying the data set, they allow for easy comparison between different data sets and help in identifying the outliers or extreme values. Next is to aid in decision making. They help in making informed decisions by providing a summary of the data set. This can be useful in various fields such as finance, marketing and healthcare. Next is to evaluate performance. Statistical averages are used to evaluate the performance of individuals, organizations or process. They help in setting benchmarks and targets and assessing process towards achieving them. This is particularly useful in fields such as sports, education and business. Now, types of averages. Basically, there are three types of averages. One is the mathematical average, second is the positional, and third is the commercial. Under mathematical average, we will study arithmetic mean, geometric mean, and harmonic mean. And in positional average, we will study median and mode. And in commercial averages, moving average, progressive and composite average. There is also one weighted average. Now, mathematical averages first. First is arithmetic mean, which is very simple. The arithmetic mean is the most common type of average. If n numbers are given, each number denoted by ai, where I is equal to 1, 2 and so on n, the arithmetic mean is basically sum of observations upon number of observations. This is the formula of the arithmetic mean, sum of observations upon total number of observations. So whereas n is the number of observations, I represent the index of summation, a is the data value for the given index. Next mathematical average is geometric mean. The geometric mean is a method to find the central tendency of a set of numbers by finding the nth root of the product of n numbers. It is completely different from the arithmetic mean, where we add the observations and then divide the sum by the number of observations. But in geometric mean, we find the product of all observations and then find the nth root of the product, provided that n is the number of observations. This is the formula of the geometric mean. Geometric mean is equal to product of the observation and the nth root of the product of the n observations. Basically, this formula is product of the all observations and find the nth root of the product of n observations. Again, where x1, x2 and x3, xn are the individual items up to the n terms. For example, if we want to find 3 numbers of the nth root, we will multiply 3 numbers x1 into x2 into x3 and nth root may 1 upon 3, because we are taking here 3 numbers. So we will take product of 3 observations and then find the third root of the product of that observation. Next is harmonic mean. The harmonic mean is defined as the reciprocal of the average of the reciprocal of the given data values. The formula is to find the harmonic mean is given by n upon 1 upon x1 plus 1 upon x2 plus 1 upon x3 plus 1 upon xn. It means average of the reciprocal of the given data values, where x1, x2, x3, xn are the individual items up to the n terms. There is also relationship between the arithmetic mean, geometric mean and harmonic mean is arithmetic mean is always greater than equal to geometric mean and geometric mean is always greater than equal to the harmonic mean. Next is the positional average. Under positional average, we will study median and mode. The median is the middle number in a list of sorted numbers, and mode is the most frequently occurring value in a set of values. The mode is interesting as it can be used for any type of data, not just numbers. In future we will also study the numericals, formulas, and merits, demerits, uses of all the mathematical averages and positional average. Next is commercial average, weighted average. First, a weighted average is most often computed to equalize the frequency of the values in a data set. In any case, in a weighted average, each data point value is multiplied by the assigned weight, which is then summed and divided by the number of data points. In a weighted average, the final average number reflects the relative importance of each observation and is thus more descriptive than a simple average. For example, a survey may gather enough response from every age group to be considered statistically valid, but the 18 to 34 age group may have fewer respondents than all other relative to their share of the population. The survey team may weight the result of 18 to 34 age group so that their views are representative proportionately. So it means a survey may gather enough responses from every age group to be considered statistically valid, but the 18 to 34 age group may have fewer respondents than all other relative to their share of the population. So 18 to 34 age group, so that views are represented proportionately. Next is moving average. Moving average are trend indicators and are frequently used due to their simplicity and effectiveness. It can be calculated for any time frame from minutes, from hours to years. Any time frame can be selected from the charting software based of your requirements. So we have studied mathematical average, positional average and commercial average. So we see that average is one of the most important statistical analysis used in every sphere of life. Therefore, many mathematicians have given so much emphasis on using averages in many advanced researches. Now, next, the summary is statistical average play a crucial role in summarizing and interpreting the data. They help in providing a representative value of the data set, facilitating analysis and decision making, and evaluating performance. A good understanding of statistical average is essential for anyone working with data. So, average is very important in statistics. Thank you.